Welcome everyone for another coffee sessions. I'm one of the hosts, David Aponte. We have, as usual, Demetrius Brinkman. We have a very special guest today. I'm gonna let Demetrius introduce him in a minute. But yeah, we're so happy to be here again.
Yes, and I am stoked because David is back. I managed to corral him into chatting with us again, and we're talking today with Julien Chamond. And he is the CTO of a little company that you probably have heard of called Hugging Face.
It's a little
Now,
company,
this
right?
is incredible for us. I am so excited to have you on here, Julian, because we all have known Hugging Face, I think, for a while. It has been one of those places. It's one of the companies that me being in Europe, it's a European based startup, if I'm not mistaken. And so it put Europe in the map for machine learning companies. And B, oh shit, I forgot what I was gonna say for B, but it's really exciting to me because you have been doing, like we were talking about just before we hit record, you've been doing machine learning as your centerpiece of the company, and that is very difficult to do. So I'm excited to dive in with you about that and hear about some of the challenges that you've gone through, hear about how you've architected things and the different infrastructure that you've come up with, and what things were on your mind in the beginning and how that's changed over time as you've grown and you've exploded. But maybe we should just start with a little intro about yourself and how you came to be where you're at.
Yeah, sure. Hi. Super happy to be on the podcast. I've been spending some time on the MLOps Slack lately, so really good to be able to talk with you guys. So yeah, my name is Julien. I'm the CTO at Hugging Face. I've been like even before Hugging Face, I've been doing some startups. Some of them in machine learning, not all of them. Used to do like some computer vision at a company that was doing one of the first mobile apps where you could do machine learning based video editing. The app was called Replay. It was an iOS and Android app. So I mean, I've been doing some machine learning and some startups for a long time now. Always been like super interested in open source. I've always kind of like tried to build stuff that was useful to other people, and as much as I could, like I try to share what I built. So anyway, yeah, Hugging Face is a machine learning company. We've been like pretty much from the beginning. We've been doing some open source, and kind of like 2.5 or 3 years ago, when Google released BERT, we open sourced PyTorch implementation of their original code, and like the adoption from the community was the reaction from the community was awesome, and so it really motivated us to keep on trying to build this simple to use layer on top of the models that were built by the top companies and universities, and make it as accessible as possible to anyone to do really cool stuff in machine learning, starting with natural language processing and now kind of like broadening a little bit in an organic way, like it's based on what the community is really building and contributing and what the community is interested in. But yeah, we're kind of like have this vision of building a community where the greatest people in AI can come together and basically invent the future of machine learning together.
That's awesome. Maybe we should take a step back what is Hugging Face? Just for those two people listening that do not know.
Yeah, so we open source. We have some popular open source software. One of the repos is called Transformer. So basically, Transformer is a kind of like a state-of-the-art architecture for natural language processing and more for any machine learning task. So we really started with this open source that's gained a lot of traction, adoption. We have like probably more than 5,000 companies using this open source in production today. So yeah, we've been like super lucky to have this open source, community centric open source that a lot of organizations and users are interested in. And since then, we've kind of like we've been building this platform on top of the open source where users and organizations can share models, share data sets, discover new models, and discover new data sets, and increasingly use the platform to also train and deploy models with the goal of bridging the gap between research and production on actual production use cases. So we have this open source and the platform kind of like integrated in a seamless way, and we are super excited about pushing a few of those directions in the next few months.
Yeah, I think that's awesome, and you said a lot of great things. I'm curious, so how did that start? This idea of we're going to open source these models. Was that just something you were doing already, or the organization was doing already, and you realized that, hey, a lot of people like this. Let's do more of this. And I guess at some point, having a sort of platform as a service or whatever software models as a service, I guess is one way to think about it. How did that like process go? I'm curious how that started and how it evolved to where it is right now. Like you said, it's like this platform and a place where you can use models and build off them. Like I know I use it for almost every competition that has any unstructured data. I've always used a pre-trained model as a starting point, because why do everything from scratch when I can get a really accurate model from someone that's already put in that work for me. So I'm curious, how this all started.
Yeah, so pretty early on, like back in I think like 2017. So like right from the start of the company, we started the company with my co-founders Clément and Thomas. Right from the start, we built this system. So we were really like experimenting with chatbots at the time. We built this co-reference resolution system. So basically, linking pronouns to linking pronouns to the actual subjects of sentences.
Interesting.
My wife went shopping yesterday. She bought some new shoes, so she is my wife, right? We built this system on top of Spacie,
I remember Spacie,
which is like a really cool NLP library. We made it like pretty fast because we had like a ton of data a ton of text to input to the system. So we dived into Cython. We made a pretty cool integration to Spacie, and basically it was way faster than the state-of-the-art co-reference resolution open source software that was available back then. So I mean, we basically released it, and I mean it's a pretty it's a pretty precise use case, right? Co-reference resolution is probably not something that you need to do like every day, like in all use cases. But we saw that there was like a big interest in the library, so we kind of like said, yeah, that's nice. Always useful to build stuff that other people can use. And yeah, that was the one of the first example of the open source that we released. And yeah, really like from the start of the company, we started open sourcing some stuff. So it was it was not like a strategy decision in a way. It was more that something that we were used to even in previous startups that we kind of like continued doing.
How did you know? When was the point where it went from just being a fun project to a company?
So it's kind of like maybe atypical, but we started with the company, right? Like we started the company. The three of us started the company back in 2016, summer of 2016. So yeah, five years ago. Time flies. Right?
Yeah, it's crazy.
And from the start, like we were like super passionate about NLP. So like the goal of the company was to kind of like experiment with a few different things in the field of NLP. Mm-hmm. So as I was saying, we experimented with some chatbots related stuff. But the goal really was to dive into NLP, dive into like modern machine learning. We had done some machine learning a few years before, which was like obviously like super different, because machine learning in 2010 was kind of like different, like super different from machine learning in 2016, 2017. So yeah, we used those first few months as an excuse to upgrade to the newest ML stuff, really dive into some more like NLP things. And pretty much like the goal was to explore the beginning.
That sounds like a lot of fun to start off that way, and then it naturally grow into something that, like you said, is useful for other people. And how did it get into the platform side of things? When did this become important to you guys?
So after a while, after we released the first version of the Transformers library, mm-hmm. which was like pretty much just a PyTorch implementation of BERT in the beginning, but then we started adding, and the community proposing to add some new models. So it's kind of like grew. Pretty early, we found out that a lot of users were interested in sharing checkpoints. So not just the code, but the weights of the models. So we basically like hacked together, like we hacked super quickly the first version of a system that let users upload their own checkpoints. It was like super hacky. It was like like just generating like pre-signed S3 URLs that we were like shipping to the client, and then the client was just like uploading weights. Mm-hmm. It was like super messy. We had like a ton of different like conflicting files in all of the buckets. So it was kind of a mess, but we validated that a lot of people were interested in sharing their models. After a while, we also found out that a lot of organizations were interested in sharing their models. So we kind of like said, yeah, that's nice. And again, as you said, like the current way of doing machine learning has kind of like moved a little bit from, training models from scratch for each use case to basically like looking for like pre-trained models that are trained on massive amounts of data in a kind of like a semi-supervised way. Mm-hmm, mm-hmm. And then basically picking one or two of those models and fine-tuning them to your specific use case. And it's a much more efficient way of doing machine learning in a lot of different subfields of machine learning. It's working really well. Obviously, in NLP, it's working really well. Mm-hmm. But yeah, in other fields, transfer learning, as it's called, is starting to really be a super efficient way of doing machine learning. So basically kind of like providing tooling, providing a platform around this change that people more and more want to start from pre-trained model and fine-tune them to the specific use case. was kind of like something that we said, yeah, that's something that's going to be big. Let's build some stuff to help people do that.
Great decision. I think because you're right in the, like you said,
Yeah.
it's more efficient to start from like a good starting point, right? It's even in terms of cost, right? Because like some of these models are expensive to train, or take a long time to train, and so you're making it more accessible for people who maybe don't have that infrastructure in place. Maybe they're dependent upon a cloud provider, which can be very expensive. So it's just making things easier is what I see. And I'm curious. Sorry, well, I just want to kind of follow along in this vein. How did you narrow down the scope of what services you were going to provide for your users? Because there's a lot of directions you can go with this, right? You could be a full-fledged, full-blown machine learning platform, right, for deployment, for training. But now you have, it seems like you needed to focus it in something that was specific to what Hugging Face was already doing. So yeah, how did you narrow that down?
Again, I mean, it's not always like conscious decisions, as much as like organically seeing what's going to be useful to users and the community in the next couple of months. So we it's not like we have this grand like vision of what, I mean, we have some kind of vision of what we want to build, but a lot of it is like the small incremental improvements that we bring to the platform. And I think it's a pretty like natural way, like a pretty sane way of building stuff nowadays. Because machine learning is moving super fast.
Yes.
So like in a year, who knows which kind of like model will be training and on which hardware and like which data sets we'll be using. So it's kind of like we have this vision, like the vision is really like to build stuff with the community. Like we have really this mindset where we want to build stuff that's useful to the community, but not just useful to the community, but also kind of like building together with the community in a way. So I mean, to answer your question, like we started with the sharing of models in terms of platform. I think is the first feature that we've been building, and then we found out that the system that we hacked together that I was mentioning was really bad for model versioning. So we said to ourselves, what can we build that's going to be like way better and more scalable in the future for versioning? And so we basically picked Git as kind of like the backbone of the versioning system, both for models and data sets. I think that the central point is really like the ability for users and organizations to store their models in a version control way, and to share them with other users. So we do have this feature of like private models, private data sets.
Yes.
But it's really the same system as the public ones. It's just like you flip a bit and then like the model is private or public. It's really the same system that we built upon.
I just want to say I love your honesty about that, like organic process of figuring it out. I think that's encouraging for listeners to hear who's trying to do something similar. Maybe they're focusing on a different problem within the space, but they're also, I feel like, doing the same thing, figuring it out as you go along the way. I don't think anyone has this space completely figured out. As you said, it's constantly changing. So that's very wise. Go ahead, Dimitrios.
And it's nice to hear that, because what we are doing too is very much so along those lines. We're basically figuring out how things work as they go along. And so it's cool to hear that it wasn't like a defined strategy that you were executing on night and day. And so was more organic in that sense. And I can relate to that with the way that the MLOps community has been going
100%.
and growing.
100%.
And so one thing that I wanted to jump into, since we are talking, you mentioned Git there, and there's a lot of stuff that you've got going on under the hood. And I'm wondering if you can dive into what you're using when it comes to not the open source side of things, but the managed service, if you call it that. I'm not sure what the official term is that you call it, but the like the model hubs, I think is how you mention it. Yeah. And what's going on there? What kind of infrastructure are you using, and how are you, like you said, assuring that you do have that provenance and you do have the reproducibility?
Yeah. So we pretty much I've been using Git for 12 years now. Love it. I think that a lot of software engineers are super used to using Git. So we use it to store models and data sets. Everything is a repo. Basically, everything is defined as a Git repository. It's not that hard it's actually pretty simple to build a simple Git server. I kind of had this intuition that this notion that building a Git server was going to be pretty hard, but it's not really, because a lot of it, Git is decentralized. So a lot of the features that you need to build around to be a Git server are actually built into the Git client anyways, right? There's not a lot to do.
A layer on top, though, I'm assuming, a nice abstraction on top of that.
Yes, exactly. So I mean, everything is exposed as a Git repo. It's nice for users, I think, to know that whatever happens, they can always Git clone their any repo, and they have they have a copy of the not only the snapshot of the model, but also the revision history of the model. So in a way, it's kind of guaranteeing that we don't build anything that's that introduces any lock-in to Hugging Face, because pretty much you're using GitHub, that you have this peace of mind that it's just a Git repo. So if anything happens, if Microsoft starts doing really bad things with GitHub, you can spawn your own GitLab instance or anything else, and you can just Git clone your repo and push it to somewhere else. So in a way, it's nice to know that everything is Git based, is super standard. The one thing that we've done, which is also building on it's also trying not to build our own system, but reusing stuff that's already happening, is large files, because obviously machine learning, you have a ton of large binary files, model weights, for instance.
So LFS, is that what you're using?
Yes, exactly. So Git LFS is a super, if you look at the actual code for Git LFS, is super simple. Again, it's building on top of stuff that's already built into Git. So Git filters.
Interesting.
So the code is not super complicated or anything. It doesn't have a ton of features, and basically it's just a way of telling Git, before committing this file, because it's so large, you're going to hash it, and you're going to upload it somewhere, and then you're just going to store the hash for the file instead of the content of the file.
Smart.
So I mean, it's a super simple way to solve this problem of how do you ensure that you have good versioning, but at the same time being able to handle large files that are like super common and super central in machine learning. So we decided to take this approach of like reusing Git because it's like super simple. I mean, Git is not simple, but people are like the community is used to using it. So instead of like building our own stuff, we decided, let's just use Git and GitLFS and see how it works. And I mean, the adoption has been like reasonably easy. I think we still need to improve a little bit, like the documentation about how we host the models, how we host the data sets. We recently, like maybe 2 weeks ago, our team shipped a Hugging Face course. So it's basically like like a course that you can follow, and that gives you like a really good onboarding on not only natural language processing, machine learning, but also a little bit the Hugging Face hub. So you see how to publish your first model, what features you have, how to use like Git and GitLFS, and the team is like super great. So they did a really great job at explaining what we built and why we built it in a way.
I love that. I love Git. I remember there was a Stack Overflow post on how Git actually works, and you're right. It's not that it's simple, but it's simpler than I thought it was going to be. It's just changing a reference to where something is, which I thought was really cool. I'm curious, in the back end of things, if you don't mind sharing with us, where are you storing these model artifacts? You mentioned that, let's say, it's being uploaded or stored someplace outside of that actual repo. You're just saving a hash. Are you using S3 in the back end? Any one of the cloud providers?
Yes, it's using S3 as a storage backend for the large files. And on top, what's really cool is that on top of S3, you can like basically plug CloudFront, so basically a CDN, which is like an AWS service that kind of like replicate or at least caches your content in a replicated way across the globe, which means that like maybe you're in South America, you're pulling a model from the Hugging Face Model Hub. It's going to be super fast because someone already pulled the same model and it's stored in a server that's like an edge location that's super close to you.
Awesome.
So I mean, I don't know how many like edge locations they have, like, but a ton, right?
Yeah, South America is definitely, they're growing in the edge locations and the data centers that they're adding down there from all the cloud providers. I think it's so cool that it's everything is becoming more connected. But anyways,
yeah, it's pretty important for machine learning models, right? Because like when you download a model and it's like a few gigabytes, and maybe you don't have like a optical fiber connection. It's really like speeding things up a lot if you can download from a location that's close by. You see like 100x faster download times, stuff like that. So yeah.
Wow. So jumping into some of these inference widgets for companies that you've got with GPUs and CPUs for the companies, and they're being run somewhere. Where are these being run? Is it also like what you were just mentioning?
Yeah, I mean, we use AWS a lot. So maybe to describe a little bit the inference API that we have, and that's powering the inference widgets. For each model on the Model Hub, we try to ensure that we have the metadata about the model to be able to actually run it. So obviously for the model from the that are trained or compatible with the Transformers library, it's pretty easy because we have this config.json file that's describing what kind of model it is, what the number of layers is, stuff like that. So I mean, for those models, it's pretty easy to do. And we recently started, partnering with other open source libraries for machine learning to let them basically host their models as well. And in every case, we try to ensure that we have the metadata inside each model repo. We have the metadata. Maybe it's a config.json file, maybe it's a YAML file that lets each of those library know how to run the actual model. So in a way, it's not just like, GitHub, when you push a Git repo to GitHub, GitHub doesn't have any clue how to run the code in most cases. In our case, we try to ensure that we and the community keep the metadata that's required to know how to run those models, like each model. So what that enables is that we are able to, on the fly, deploy inference endpoints for each of the models. It's deployed on the fly, which means that maybe for like a model that's super popular, it's going to be already loaded, so you can already, send a request and get the result instantly. In some cases, the model is not loaded yet, so you need to you can pass like a flag to the request that you're doing, and the request is only going to respond after the model is loaded, which, depending on the model size, can take from a few seconds to maybe 10 or 20 seconds. So we have this infra, and I mean the infra itself is built on top of like the standard modern ways of deploying infra, so like Kubernetes.
Did you build anything custom to for, I guess, like to deploy that? Is it like a Pythonic API under the hood? Are you using like a Lambda function? What are exactly you using to what are you loading that into is what I'm curious about, if you don't mind.
So I mean, it's custom containers.
Got it. Okay.
Custom images, depending on the model, depending on the library, we optimize those to make sure that they run as fast as possible on the target hardware that we have.
Got it.
But then basically it's just like, Kubernetes instrumentation, pushing container X to hardware Y, for any model that we have.
That's cool.
That's pretty much it.
Yeah, we've a lot of. I think that's like a very common pattern. That's cool, though.
Yeah. What's really cool is that so this inference API is powering the widget, so it's free to use. You can play with any model on the Model Hub directly on the web page. We do have more and more companies that are our customers that are interested in specific models, and they have latency constraints or super massive volumes of requests. And in those cases, we work with those customers to make sure that we put in place the right optimizations for the use cases. And I can go on a little bit more about all the potential machine learning inference optimizations, but maybe we can talk about it for maybe 3 or 4 hours.
That sounds like a fun subject.
But basically, we work with those types of companies to make sure that for their use cases they have the specific performance that they need. Sometimes we even help them ship on-prem.
Oh, cool.
So when the network latency or the privacy or security requirements are too high, they need to basically run the API on their hardware. So we also have like a way of like shipping a container, and it's pretty easy for them to run it. Most of the companies nowadays have access to like on-prem Kubernetes cluster. So it's just a matter of like specifying that you need this type of underlying hardware. Because as you know, like machine learning is still like pretty much like hardware dependent. And then like you get this API endpoint. And what's really cool is that, like BERT is kind of like the most popular model. If you use like it's pretty easy to deploy a web server on top of BERT from the open source. You're going to have like decent performance without any optimizations. Like maybe it's going to take like 50 milliseconds per inference, maybe 100 milliseconds per inference in some cases. When we turn all the optimizations all the way, we can provide up to like a few million BERT requests per hour for some of the customers in sub 1 millisecond response time.
Nice.
I mean, if you really like dive into optimizations, you can do like pretty crazy shit. Nowadays.
I bet, right? I mean, there's like the standard quantization, but I'm sure there's all sorts of things that you're doing. I'm curious, are you guys thinking about like using different types of hardware? I mean, TPUs is like a very Google-centric thing. I don't know if anyone else is going to be doing that, but I know, for example, at Microsoft, there's FPGA, so Field Programmable Gate Array. So that's like a new thing because that can evolve as the machine learning evolves. At least that's the idea. So how do you guys think about the hardware specifically as you grow?
Yeah, I mean, for training, so we talked a lot about inference. For training, it's basically like all over the place. Like people are using like such a huge variety of hardware. It's pretty crazy. You mentioned TPUs. TPUs are used a lot because like Google is pushing them a lot. It's also like pretty efficient. So like here, if you're using like JAX or FLAX, for instance, it's pretty much like optimized for running on top of like TPUs. So you get like crazy efficiency.
Awesome.
Some people are using like even more custom hardware. So, there is this company called Cerebras. I don't know if you've seen that.
I think, that sounds familiar.
So they do like wafer scale chips. So basically when you build like chips, CPU chips, you start from like a piece of silicium that's like a cylinder that's that size about, and you get like also you cut it in like super small pieces because it's really hard to make sure that you don't have any faults inside of like a wafer scale chip. What they do at Cerebras is that they have this novel manufacturing process where they are able to work around the failures on the wafer, and so they have this crazy, like it's basically like a GPU, but like 10 times larger.
Yeah, that's what exactly is a huge GPU.
Yeah,
that's
so
so
I mean,
cool.
for training, like people use all kinds of stuff. For inference, is a bit more centered on like more common hardware. I would tend to say that most people use either like GPUs or CPUs for inference. What's really cool is that for CPU specifically, it's like super cheap, like CPU servers are super cheap. If you are able to run BERT sub 1 millisecond on CPU because you have really cool and really powerful optimizations, you don't really need GPUs anymore, right?
Yep.
So yeah, I mean, it's really exciting because then it's really cheap, it's really cost efficient. It's also like energy efficient, which is also important. So I mean, all the optimizations that we can help with, we try to help with them.
I love that. And I feel like that's such a fun space to be in. You're at the intersection of software and hardware, machine learning. So you have a little bit of everything that Hugging Face is, I guess, getting to deal with. That's really exciting.
Yeah, and that's one thing that I noticed with, and I used to ask myself this so much is what is ML ops? Is the hardware considered a part of ML ops? And does the hardware that you choose that has an effect on all of this that we've been talking about, does that mean that you're doing ML ops when you're choosing that hardware? And so it's cool to hear about this. It's definitely something interesting. Now, I know we're coming to the end of the session. And so I'd love to just take a step back real fast and hear about some of the challenges that you've had over these past couple of years while you're building up this company. And while it is exploding and it's growing at such a rapid pace, what are some things that you've learned over this time and hopefully you can pass on to the rest of us so we can also learn?
Yeah, I mean, for me, my personal learning is that, I mean, it's gonna sound like super cliche, but the team that you assemble is everything, right?
Oh, yes.
If you manage to onboard people who are super talented and give them a super large level of freedom and autonomy, while making sure that everyone is kind of like working well together, they end up like building great stuff. And I mean, we knew that obviously, because you read about these things all the time. But it's it's been an incredible thing to witness, like onboarding people, making sure that they work well together, and then seeing that they can build like amazing things. Again, like the community is at the center of everything that we are doing, so it's also a way of motivating everyone. You get like super excited, waking up every day and knowing that you're going to be able to chat. In the morning, you're going to be able to chat with super talented students in India. In the afternoon, you're going to be able to talk to like a machine learning engineer who's based in Vancouver.
Love that.
Yeah, really have this connection to the community is amazing, and it's something that we are trying to foster more and more.
There's a lot of parallels between I think
So
what
many.
you just described and what we're doing. Sans the platform and all the cool things that you're doing, but like you said, the people are really important. Shout outs to Vishnu and Ivan who always work with us on these things. But yeah, the team makes or breaks, I think, a lot of the success that you have.
And so maybe to finish up as one of our last questions, do you have any war stories over these last couple of years that you can share with us?
I mean, you get like ups and downs. Most of it though has been like, because we have this passion for what we're doing and this team that's also like super passionate about the vision. We kind of like if I reflect on things, we have been like pretty happy with what we've been able to do so far. I would say that the goal is more like forward looking, to make sure that we can be as helpful as we can to the community, to really scale. I feel like it's like still super early, I'm kind of like thinking that machine learning is going to be as big as software engineering, or maybe even bigger. What like if you provide tools for the community, how do you make sure that those tools scale with the community? Is it going to be like, is it going to be harder and harder for beginners to get onboarded into machine learning, or is it going to be, easier and easier? So I feel like we need to stay focused on what's going to happen next, and hopefully make things that are scaling to the large numbers of people who are going to learn about machine learning in the coming years. And it's just not just for Hugging Face, but it's for the whole machine learning community, right? I've been thinking that GitHub is kind of like this place where some communities interact. I feel like GitHub is like a super positive company. It's had like a huge impact on our activity as like software engineers. Mm-hmm. But at the same time, it's it's like a bunch of different small communities, like small or large. But the Python community on GitHub is not really interacting that much with the front-end JavaScript community. Mm-hmm. And with the machine learning community. With machine learning, it's kind of different because it's all super connected. Absolutely. It's the same tools, it's the same frameworks, it's the same general principle of approximating the function on a specific domain, using a data set as kind of like an input domain, and learning to map an input to an output. There's not a ton of things that are like super specific to one or the other field in machine learning. So how do we make sure that the level of like involvement of the community keeps on increasing, even when the community is getting larger and larger? I think it's going to be like a super important thing to work on.
This is what I think about every day. It's amazing, the parallels here.
Yeah.
So
I think we may have to collaborate in the future, Julian. I think we may need to do something together, because we are also in the space of trying to make machine learning, specifically MLOps, more accessible for people. And there's just a lot of noise in this space. So things that help scaffold the learning, that clarify things, that break things down, go a long way. I just want to shout out also to the course that you guys released. You guys recently put together like a course, a Hugging Face course, to get a sense of how to use your ecosystem. It's really great, really clear. It's nice. There's like modules that are bite-sized that you can do like in a quick little, lunch break if you want to find out how to use it. And like I said, it's a great place to start in any machine learning project, specifically if you know that you're going to be working on a lot of unstructured data. Transfer learning is, I think, one of the ways to go. I guess I get why some people don't want to do it, but it's definitely something worth considering as you start a project. I guess as we close, you definitely work a lot with open source. So people who are interested in getting involved in working with you guys, contributing to that, where can they contact you? What do they need to know to get started with this?
Yes, I mean the course is probably a good way of starting to get on board the community. We've tried to make it as accessible as possible, while still, learning, like teaching you a ton of stuff on NLP and machine learning. So hopefully it strikes the right balance between accessibility and sophistication in a way. I would love to have your input, your insight on the course, as well as the MLOps community. I think it's a perfect way to to try things out and to learn about those things. Specifically on MLOps, we are in, like, for instance, we again, like, this organic way of designing new features that are going to help the community. We found out a couple of weeks ago that some users already had uploaded their TensorBoard traces to their model repos.
Mm-hmm.
So basically, we found out that, like, people were training their models and then uploading the traces, the TensorBoard files
That's
with
awesome.
the model. So we basically we implemented a TensorBoard server that's kind of like integrated seamlessly inside the Hugging Face
That's cool.
website. So now, like, whenever you train a model, you can store and upload the TensorBoard traces, and you get a nice, like, TensorBoard dashboard for your training.
That's
so
awesome.
it's not just about storing the final version of your model anymore, but it's also storing the training artifacts and the way to get to the final version of your model. So in some cases, I think it's going to be, like, super useful.
Absolutely.
Would love to get your feedback as well on this feature.
I love that, because that enables reproducibility, right? Auditing, all those things are the challenges that MLOps is trying to address. So yes, I am very much interested in that.
So anyone out there that wants to get involved, get after it. That's all the time we got for today. This has been incredible. Julien, merci beaucoup. And also shout out to David, because I think he's being held hostage in a dry cleaners right now.
I'm at my mother-in-law's. Yeah.
Blink twice if you need us to come rescue you, Dave.
Awesome.
Sorry, man. We couldn't use. He wanted to use the background fake thing that you can use in Zoom, but we're not doing this on Zoom because the quality is higher on Zencastr. Anyways, we're out of here. See you all later. Thanks again, Julien.
Thank you.
This was awesome.
Yeah. Let's keep in touch. Bye.